Hello everyone, welcome back to channel. I am Nikhil Kumar. In the last video, we enabled HTTPS on Gateway API using a manual OpenSSL certificate. It worked, but it's definitely not how we do things in the real production. So today, let's step into a real world. We are going to automate HTTPS using Cert-Manager. So we will install Cert-Manager, create a cluster issuer, automatically generate a TLS certificate, and then attach it to a Gateway API. So there is no manual certs required, no rotation headaches, and everything is fully automated.
Before we install anything, let's quickly understand why we even need Cert-Manager. In the last video, we created a TLS certificate manually using OpenSSL. That's work for demos, but it completely breaks down in the real environment. Here's why. First, certificates expire. Every few months they need to be renewed, and doing that manually is risky. If you forget even once, your entire site goes offline. Second, scaling becomes impossible. If you have multiple microservices, each with their own host name, that means multiple certificates. Managing all of them by hand is not a practical solution. Third is security. Manually generating certificates means private keys often sit on local machines, desktops, and the laptops, which is not a safe practice. And finally, DevOps rule number 1. If something repeats, automate it. Certificates expire, rotate, and renew. These are repetitive tasks that should never depend on a human. And that is exactly where Cert-Manager steps in. It automates certificate creation, certificate renewal, rotation, secrets update, and integration with Gateway API, Ingress, and the APIs. Behind the scenes, Cert-Manager uses ClusterIssuer or the issuer who issues the certificate. Certificate object what you want issued, and secrets where your TLS certs are stored. For this demo, we will use a self-signed cluster issuer. It's perfect for local cluster. So let's get started with the Cert-Manager installation part. So this is my Kubernetes cluster, which I used in my previous demo, where we configure the manual TLS for the Gateway API. So first we will install the Cert-Manager. So for that, I am going to use a GitHub repo path along with the kubectl apply command. So this installs the main Cert-Manager controller, the Webhook, and the CA injector, and all the CRDs needed for the certificate. So let's quickly verify the pods. So for that we can run kubectl get pod -n cert-manager, and we can see all the 3 pods are running fine. If they all are in the ready, that means we are ready to move on. Now let's create our certificate authority, a cluster issuer. For that, I have already created a file. So let me do ls, and this is the file for the cluster issuer. So let me open this. Think of this file as a certificate authority that signs our certificates. So at first, I am using a CRD, that is a Cert-Manager one, which we installed using a kubectl apply command along with a GitHub repo path. Then I am using a kind, that is cluster issuer. Then I am giving a name to this cluster issuer, that is a self-signed one. Because I'm going to use a self-signed certificate in this demo, under the specification, I'm using a self-sign. That means it tells Cert-Manager to generate its own temporary CA. So let me apply this. So, kubectl apply -f cluster issuer.yml. So the cluster issuer got created. Let's verify that. So kubectl get cluster issuer, and we can see the cluster issuer got created, and here we can see in the ready it's true. That means our issuer is working fine. Now let's request a certificate for our host name. So for that we need to create a file for a certificate request. So I have already having a file. So this file is used to create a certificate for our host name, that is master01.local. Similar to the cluster issuer file, here also I am using the API version to specify the CRD, that is Cert-Manager. Then I am specifying the kind, that is certificate, and under the metadata I am specifying the name of this certificate, that is colors.cert, and under the specification I am specifying the secret name. So the Cert-Manager will store the certificate and key in this Kubernetes secret. So this particular secret will be automatically created by our Cert-Manager. In the previous demo, we created a secret manually using a kubectl command after we generated a certificate and the key using the OpenSSL command. But in the Cert-Manager, this part has been automated using a Cert-Manager itself. Then below that we have a duration. That means this is the validity of this certificate. For the demo purpose, I am setting it for 1 day, that is 24 hours. After that, we have a keyword called renew before that is set to 12 hours. That means it will renew the certificate automatically before the expiry. Then we have an issuer reference. It tells Cert-Manager which issuer to use. So we just created a cluster issuer that is self-signed one. So I am specifying the name of that particular cluster issuer and along with the kind, that is cluster issuer. And at last we are specifying the DNS name. So the certificate will be valid for this hostname only. Let's apply this. So let me save and exit and kubectl apply -f certificate.yml. So the certificate got created. So let's quickly verify that. kubectl get certificate. We can see the certificate got created. That is true. And it also shows the secret information, that is colors-TLS. That means this certificate got created and it got stored under the secret called colors-TLS. So let me describe this. kubectl describe certificate. Here we can see what's happening behind the scene. So the Cert-Manager generated a private key and then it creates a CSR, and after that it signs it using our self-signed CA, and at last it stores the result in a colors-TLS secret. So let me check that as well. So kubectl get secret. So this is the secret got created 2 minutes ago, that is colors-TLS, and the same name we can see here in the certificate description, that is secret name is equivalent to colors-TLS. Now the Cert-Manager has created a fully automated certificate for us, and it's time to attach it to our gateway. So for that, let me update a gateway file. In the previous video, we updated the gateway file to add a listener section. So this is the same block which we have added in the last video. So in this one, we just need to update the secret information because that secret is being managed by the Cert-Manager now. Earlier, we created a demo-cert. This is the one which we created manually in the last video when we used the OpenSSL command to generate a certificate and the private key, and after that we created a secret, and the same secret we have used here. But this time we have another secret that is being managed by the Cert-Manager. So for that, let me update this name here. So instead of demo-cert, the name should be colors-TLS. So let me save and exit and let me apply this. kubectl apply -f NGINX gateway.yml. So the gateway got configured. Now let's see kubectl describe gateway and the colors-gateway, and if we scroll up here we can see the certificate information got updated. Now it's time to test the application, so let me do it very quickly. So kubectl get service and do call here -k and HTTPS master 01.local and the node port of the HTTPS and / that is a path, and our application is working fine with the new certificate which is being generated by the Cert-Manager. Now let's summarize everything which Cert-Manager automated for us.
In this video, we installed Cert-Manager, created a cluster issuer, requested a TLS certificate, and then automatically generated, signed and stored the secret, and at last connected that secret to a gateway listener. In the next video, we will take a real ingress application and migrate it to a gateway API using NGINX Gateway Fabric. If you found this helpful, hit like, share it with your friend, subscribe for more content like this. Thanks for watching. I will see you in the next one.